So with the summary of stress transformation and stress block, the other method that can be used to do the stress transformation with the graphical presentation and invented by Mohr, then that we call it Mohr's circle for stress, and that we had some note here before we move on for worksheet D and E. Mohr circle for stress. Both method, when we do for worksheet 12A to C, that we use analytically with the equation, now we can use graphical solution to find out that. So what is that about of the Mohr circle? It's basically a graphical representation where each point on the circle represents a stress on a different plane. So each point on the circle, at its name implies Mohr circle. So on the circle represents a stress on a different plane. And the most confusing when we do the Mohr circle compared to the stress transformation is the sign convention of the shear stress, and that keep that in mind a little bit different that I'm going to discuss now. So sign convention. So in terms of the stress, we have the normal stress and we have the shear stress. So for the normal stress, the sign convention for the Mohr circle is exactly the same as the analytical method with the equation we discussed above. So it will be tension is positive and compression is negative for the normal stress. So let's write down here. We have tension, it will be positive, and compression it will be negative. The difference for the sign convention of Mohr circle and the analytical method we talked earlier with the equation is the shear stress. Shear stress. And what is the sign convention in the analytical method that we already discussed? So if the shear stress follow the positive y or x-axis on the positive x or positive y plane, that we call it positive. For example, tau xy. If the tau xy go to the positive y-axis, then that is positive in analytical method both with the equation. But here it's a little bit different. If the shear stress create clockwise, then it's positive. Clockwise rotation, then it will be positive. So as you can see, a little bit straight. Normally we say counterclockwise positive, but for the shear stress, only the shear stress in this case, everyone, we will have something later on when we determine the theta with the equation that you see here. But for the shear stress, when you see the stress block, to use the Mohr circle with the shear stress, if it's clockwise rotation, tend to rotate the block clockwise, then it's positive. And then, of course, if it's clockwise positive, then we have it counterclockwise, it will be negative. Okay, so with that, and if you are not sure, then you can go ahead to find out with the study guide that we have the definition of that. So let me state here that the sign convention for the shear stress for Mohr circle is different from what we learned in the sign convention for the shear stress that we use in discussing states of stress and state of strain later on when we do with the analytical method in there. So if you want, you go ahead to read the summary in the study guides, or I can make a summary in here so that before we move on. So if we have, give example here, if we have block, and that from the study guide, by the way, and you have that here in plane. So in x plane, we have that is tau xy, and we have that is sigma x, and of course the other way it have to go that, and you have sigma x as well. And then the opposite, the y direction, we have it sigma y. I assume it in tension. And then we have tau opposite to make it balance, and you have sigma y in here. So just the same. So let's erase that one to make it simpler. So from that, as you can see, if we look at the information for the sign convention, so in the analytical method above, in this case we have sigma x positive, sigma x in negative, because it makes the block in compression. So it's nothing new. So that's the same sign convention for the Mohr circle and for the analytical method. Sigma y is in tension, right? Go out of the plane, so it's in tension. So with that intention, it's positive. So in this case, both, if you use the equation on the equation that we discussed here, then in this block, we have sigma x is negative and sigma y is positive. Now, the difference is only the shear stress. So how is different? In this case, if you have the tau xy is tau xy in this case, as you can see, it go same as the positive y-axis, going up, similar on the x-plane. Then the tau xy in this case, as you can see, I can write down here, so you can see it positive in analytical method. Analytical method, because tau xy is go same as positive y direction, but at tau xy, based on the sign convention here, is tend to create the counterclockwise for the block, the blue block there. So it counterclockwise negative. So as you can see here, it will be negative in Mohr circle. So that something that you need to stay focused, because that the most confusion we have. So it's only applied for, and you can see the stresses. So don't confuse that in that situation. And of course, the other way that you can have it later on. So that one thing is only confused when we have Mohr circle. So let's move on to the equation for the Mohr circle before we practice worksheet for 12D and E. So general equation for a circle. And if you know what is the equation for the Mohr circle, and of course, as you can see, x in your calculus, x minus a squared plus y minus b square equal to the radius square. So for any point on the circle, it will have that equation, and in that case, a and b is the coordinate of the center of the circle. So let me write down here, if we have a circle on the x and y plane, and as you can see, for let's write circle here, and the center of the circle is there, then we have that is a, and we have the coordinate in y is b, and the radius, as you can see there. So any point on the circle have that, and the radius of you got here, that is the radius of the circle. So you have that general equation for the circle. Now, Mohr circle is the same concept, right? So, but how we determine the A, B, and R, and then we can make the circle, right? So the center, we need to know where the center and what is the radius. Then we can make the circle. So the center of Mohr circle, which is the AB based on the general equation that you have there. So what is that for the center of the Mohr circle? AB, the coordinate AB for the Mohr circle is equal to, very simple, sigma x plus sigma y over 2. As you can see, if you recall, that is the sigma average times O, and the y coordinate equal to 0. Or it can also be equal to sigma, as I mentioned, sigma average. So location to find out sigma average, and the center of the Mohr circle is always located on the x-axis, because the y component, the b, equal to 0. And then we know the center. Now we find out the radius. So the equation for the radius of circle, and that is r in the general circle equation, equal to square root of sigma x minus sigma y over 2 square plus tau xy square. If that square root is familiar to you, if not, I just go it up here to see the maximum in plane shear stress. Tau max equal to sigma x minus sigma y over 2 square plus tau x y square. So actually that radius equal to tau max, the maximum of the in plane shear stress. So with that, we have the center of the Mohr circle and the radius of the Mohr circle, and by definition of the Mohr circle is a graphical representation where each point on the circle represents a stress on a different plane. In this case, the x stands for the normal stress and the y direction stands for the shear stress. And that we will practice that in the next two problems, 12D and 12E, and then you will have that with the same problem we do, but now we did A and C, and then now we do with the Mohr circle. Everyone okay? So, but sign convention is very important. Don't be confused, especially the shear stress between the analytical method and Mohr circle. With that, move on to practice the last two problems.